We're into slightly deeper waters now, and the first thing we're going to talk about in this video is the cardinality of a set. Now, what's the cardinality of a set? Well, in simple terms, if you've got some set A, we write the cardinality as A between two vertical lines, and that is just the number of elements in A. And that's all it really is in when you have finite sets anyway. So the number of elements in, say, A, where I'll write A equals 1, 10, 12, 17 and 103, why not? And the cardinality, I'll write over here, cardinality of A is 5, because there's 5 elements in A. That's all it really means in simple terms. Now, a countable union, what do we mean by a countable union? Well, in the previous video we mentioned that a union is simply when you have two sets and you want to include both of those sets in their entirety. But when I say a countable union, we might have more than two sets. We might have some sets A1, A2, A3, and so on, up to some AN. So we have a family of sets, and their countable union is written like a big union symbol, where we have starting at k equals 1 and going up to n. So here we want k to go from 1 to n, where k is this little index down here. So you've got the 1, 2, 3 up to n, and that's just a k. So what this means is A1 union A2, right, equals there, union A3 union, all the way up to the union with a n. And that's all it really means. You can probably work out what the countable intersection is just from what I said the countable union is. So when you have some family A1, A2, all the way up to a n of sets, and you want to find their countable intersection, all that is big intersection from k equals 1 to n of the AKs, and that's just A1 intersect A2 intersect all the way up to the intersection with a n. So it's the set of all elements where the elements are in all of the A's. So if your x is in the intersection, the countable intersection, then that means your x is in A1 and it's in A2 and it's in all of the sets up to AN. Now the power set is quite interesting. We define the power set as all subsets. So what this means is that when we have, say, some set A is a set, the power set we write as 2 to the power of A. So that's the power set, 2 to the A, and that's equal to the set subset E in A. So that's all of the subsets of A. And why do we call it 2 to the A? Well, that relies on how many subsets there are in some sets. So let's say that A is finite, so that means that A has a finite number of elements in it. And let's say that the cardinality of A is some n. So n is how many elements there are in the set A. Now, what do I mean by subsets? Well, subsets are any collection of elements in A, and we know that the number of elements in each subset is going to be less than or equal to this n, which I've defined over here. But how many ways are there to choose a subset with one element in? Well, so subsets with one element, there's going to be what we call n choose 1. And this is just say you've got however many elements and you want to choose one of them. So you might want to choose this one. How many different ways are there of doing that? Well, you've got this way, you've got this way, you've got that way, you've got however many there are, and it turns out this is just equal to n. You can do the same with 2 element, and that's just n choose 2, and there is a formula for this which I'll go over in a different video. But basically you want to add up all of these, so all of these, n choose 1, n choose 2, and so on, and then that gives you 2 to the power of n. The total number is actually 2 to the power of n. I'll show you why in a different video. But yeah, that's more difficult set theory, but hopefully not too difficult. Let me know if you've got any questions with that.